So I'm gonna do a work energy related problem here. This particular problem says that the only force acting on a 2 kg object as it moves along a positive x-axis has an x component, Fx is equal to minus 6x Newton. So the object is going in positive x direction and its mass is given, which is 2 kg, m is 2 kg, which is good. And then it says that the force which is acting on it, that has minus 6x. So Fx is the x component, that's the only component for this force, and that is minus 6x. That means it is working in the opposite direction, 6x in that direction. So we need to the velocity at 6x is equal to 3 is given 8 meter per second. So when x is equal to 3, velocity is 8 meter per second, and when x is equal to 4, we need to find what's the velocity of the body at x is equal to 4. That is what we need to find. So basically the object has a kinetic energy half m v1 square when it is it has the 8 meter per second velocity, which is when it is at x is equal to 3, and at x is equal to 4 we don't know what's the velocity, but let's say the velocity is v2, so that will be half mv2 square, and this difference of energy, kinetic energy, will be the work done by the force to basically stop the object from moving. So if we do that, that will be, if we need to integrate the force, which is Fx times in dx, so 3 to 4, because this is 3 when x is equal to 3 and this is when x is equal to 4, so that's there. So this is half into 2 into 8 square, which is 64, minus half into 2 into v2 square, which we don't know, that's our unknown here, and this one is 6x. So observe here that I have written initial kinetic energy minus final kinetic energy. Actually, if the force was positive, it was force, if the force was aiding the energy, so it was if the force was in the same direction basically, then it would be 6x, and then the difference in the kinetic energy would be final kinetic energy minus initial kinetic energy. But since I know that the force is in the opposite direction, so I don't have to write the minus sign anymore, because the minus sign is already incorporated, since I am doing initial kinetic energy minus final kinetic energy, because I know that the kinetic energy will reduce. So that minus sign of the force has been taken care of because of its initial minus final. If the force was in the same direction, it would be final kinetic energy minus initial kinetic. So what I will do in the integration, I won't write the negative sign anymore, because it is already incorporated. So that's 6x here dx, and then 3 to 4. So this is 64 here, and then this is v2 square, and this one is 3x square, 4 and 3 there. So this is becoming v2 square is equal to 64 minus, I'm taking that in this side, so that's 3 into 4 square minus 3 into 3 square, basically that integration. So this is 64, and then 4 square is 16, and then so basically if I take 3 out, that's 16 minus 9, so 64 here minus 3 into 7, so that's 64 minus 21, and that's 9 there. So what's happening here is this one is 43, so v2 is square root of 43, which is 6.6 meter per second, so approximately. So that's the velocity. Now there is a second part in the problem which says at what positive value of x will be the body will the body have, anyway it's will the body have I don't know what it's trying to say is, after positive value of x will the body have a velocity of 5 meter per second. So at what x value the velocity will be 5 basically. So what it means is we know the velocity, what is that. So basically we need to do the integration again, and then that's dx, and we don't know what is the upper limit if we start from 3. So that we need to know. We can call it an uppercase X maybe, and that will be half m. I have written it, the force as positive, so I will do the initial kinetic energy minus the final kinetic energy. So this is now half into 2 into 64 like before, and this is half into 2 into 5 square, which is 25. So 64 minus 25 here. So this is 39, and on the left hand side it will be 6x again. So 6x dx just like before, and that's that. So this will be 3x square. So upper limit 3x square minus 3 times 3 there, 3 square. So that will be equal to 39. So 3x square will be, that's 9, and then times 3, 27. So 39 plus 27. So x square will be 39 plus 27 divided by 3. So x is square root of 22, which is 4.7 meters. So at that x value, the velocity will be 5. So basically here what I did is 6x, the integration of 6x, which is 3x square, and I have written the upper limit, which is unknown x, uppercase x, 3x square minus 3, and the lowercase value of x is, lower limit of x is 3. So 3 times 3 square here. So yeah, so what happens after that is that 27 is on the right hand side, and finally it solved the unknown x, which is the uppercase x. So that's 4.7 meter. So this is the second part of the problem. So basically the force is trying to stop the velocity of the object. As a result, it is losing kinetic energy, and that lost kinetic energy will be equal to the work done by the force. Basically that's what's happening. And if the force was aiding the object, then the work done would be equal to the gain of the kinetic energy.